In this one, we're going to have a 10, a 20, and a 30 ohm in parallel. So if they're hooked up in parallel, the way we would draw that is we would have our power source, and then we're going to come down and we have a resistor, and then we have another resistor, and we have another resistor, and those are our three. So I had this one was 10 ohms, this one was 20 ohms, and this one was 30 ohms, and it was across household voltage. So the voltage here would be 120 volts, and we're pretending it's a battery instead of this. Anyway, but that's what it looks like. So the effective resistance, if we are in parallel, how do we find effective resistance?
1 over.
Yeah, we say the 1 over RE equals 1 over 10 plus 1 over 20 plus 1 over 30. So we get 10 1 over x plus 20 1 over x plus 30 1 over x equals 1 over x, because I don't want 1 over RE, I want RE. So, and that gives me 5.45 ohms. Now, what is the current through the 20 ohm resistor? Well, again, here, since if you're in parallel, they're hooked up essentially separately. So this one, the current just runs right through here. So I'm going to have 120 divided by the 20 is going to give me, what do you know? That's going to be 6 amps. Really tough, right? In question number 4, we have a 15 ohm resistor connected in series with two 10 ohm resistors in parallel and a 120 volt generator. So if we make our little generator instead of a battery, it'll look prettier. So that's going to be 120. And we're going to connect a 15 ohm in series with two 10s that are in parallel. So we would draw it like that. Isn't that creating? Okay, so the total current in the circuit is going to be the current going through the 15 ohm resistor, right? So we first have to find the effective resistance of the entire thing. So the 15 is just 15, but two 10s in series in parallel act like a 5. So yeah, so this is like a 5. So the total is going to be the 15 plus the 5 is going to give me a total of 20. So then we're saying, well, the total current in the circuit is going to be the total voltage over the total resistance. So we're going to have 120 divided by 20. And we say, hey, that looks like it's going to be 6 amps again. So the current going through the 15 ohm resistor would be 6 amps. And the 10, since they're both the same size, then we're going to equally divide the current. So each of these would have half of that, so the current of each of those would be 3 amps. And then if we want to know the voltage drop, again, the voltage drop is going to be how much voltage do I lose going through that resistor. So V equals IR. So I say I'm going to lose, if I have a current of 6 amps going through 15, 6 times 15 is?
30.
90.
30. That's not good. It's actually 90.
Yeah. So V equals IR, 6 times 15 is 90 volts that we lose there. So that means we lose the rest of the voltage going across the 10. That's it. Super duper simple.
How amazing.
I can see why you were having trouble.